This is Jeremy Clark of JeremyBytes.com, and today we're going to continue our look at C# generics. Last time we looked at how generics can add type safety to classes, such as collections. This time, we're going to look at interfaces and see how generics can help us add flexibility and reuse to them. Let's review what generics are. Generics are classes, structures, interfaces, and methods that have placeholders, type parameters, for one or more of the types that they store or use. We commonly see generics in collections, especially list of T. We also see them in interfaces like we have here, an iRepository of T key. And this is what we'll be concentrating on today. We also see interfaces with methods. So here we have a get method that has a generic type that actually acts as its return value. And what benefits do we get from generics? Well, we get type safety. We saw when we were looking at collections that generic type parameters limit our class to work with a particular type. This allows us to use strongly typed objects when we're dealing with our particular classes. Generics also give us a performance benefit. They prevent the boxing and unboxing that's required when we use non-generic types. And generics also provide us with flexibility and reuse, and that's what we'll be focusing on today. Generics actually allow us to use a single class, interface, or method to interact with a variety of different types. This way, we can have a single type or method that can be used in many different situations. Here's a preview of what we'll be looking at today. We're going to be looking at a repository interface. This allows us to interact with data through an abstraction. That way, our application code doesn't need to know anything about a particular data store. Here's a code snippet for an iPerson repository. This has methods like getPeople and getPerson that will actually pull data from the data store and provide them to the rest of our application. Now, the magic of an interface is that we don't care what's on the other side of it. All we care about is this abstraction. Now, as you can imagine, in our applications, we probably have more than one object that we need to interact with. What if we needed a product repository as well? Well, we could create an interface for the product repository, but if we look at these, we see that these are very similar in a lot of different ways. Wouldn't it be better if we could create a single interface that would work in both of these circumstances? Well, that's exactly what generics allow us to do. We can create a single repository and put in generic type parameters for the things that are different across our objects. That way, we just have a single interface that we can reuse in a variety of situations. So let's go to the code and see this in action. So here we are in Visual Studio. Let's start by running our sample application. Here we can see we have a series of buttons, one for a non-generic list and one for a generic list. Those are the two options that we looked at last time. This time we'll be focusing on the repository button. On the right-hand side, we have a list box, and this will have our data that's coming from our repository. So let's start by talking a little bit about repositories by looking at the interface. Inside our generics.common project, we have something called iPerson repository. This is an interface that's designed to work as an intermediate layer between our main application code and whatever data store we're pulling our data from. For this particular solution, we're using a WCF service, but we could just as easily create repositories that connect to SQL servers, text files, Oracle databases, cloud servers, and NoSQL databases. If you want more information on interfaces and the repository pattern in general, you can check out the materials I have on my website, IEnumerable, ISavable, I Don't Get It, Understanding .NET Interfaces. You'll be able to find those materials through the links in the video notes. So the short version is that we can think of an interface as a contract. Here we have an interface with 6 methods: getPeople, getPerson, addPerson, updatePerson, deletePerson, and updatePeople. Now notice these are just the declarations of the methods. It will be up to our actual repository class to provide implementations for these methods. Now there are a number of ways to implement repositories. Here we have what's known as a CRUD repository, where CRUD stands for create, read, update, and delete. And if we look at this, we can see we have a create method in add person. We have read operations in get people and get person. We have update operations in update person and update people. And we have delete operations in delete person. Now today we're going to limit ourselves just to the get people method for simplicity, but this would apply to full repositories that we could use in our applications. Now that we've seen this interface, let's look at an implementation. If we come down to our generics.repository project, inside our person repository, I have a class called person service repository. Now what's important to note about this class is it does implement iPerson repository. Because of that, it must have those 6 methods: get people, get person, add person, update person, delete person, and update people. Now this particular repository itself is actually quite simple. It basically acts as a pass-through to a WCF SOAP service. So we can see that in our constructor, we actually create an instance of the proxy to that service. And then inside the getPeople method, we just pass the call through to the service directly. Now, when we're dealing with this particular repository, we are dealing with person objects. Let's go ahead and right-click and see what we have here. So if we look at the definition of person, we see it's a very simple class. It just has 4 properties: a first name, a last name, a start date, and a rating. This is the same object that we used in part 1 of this series. So now that we have this actual repository, let's go back to our UI application and start using it. So we'll go to our generics.ui project and look at the code behind for our main form. Now again, previously when we were looking at non-generic collections and generic collections, we went ahead and put some code on those buttons. This time though, we'll be looking at the repository button. So we'll start by creating an instance of that person service repository. So this will be an iPerson repository called repository, and we'll set this to a new person service repository. Now I already do have all of the references that are needed and the using statements so that we don't need to add anything to this particular project. So now that we have this repository, we can actually call that getPeople method. So let's say var people equals repository.getPeople. Now, if we look at the return type for getPeople, we see that this is an IEnumerable of person. So this will return us a group of objects that we can iterate through with the for each loop. Now, var is just a shortcut. If we hover over this, we see that this is also IEnumerable of person. Just to make this clear, let's go ahead and add that in. So now that we have this collection of people objects, we can just for each through it. So we'll say for each person and people, person listbox.items.add person. And now when we run our application and click on the repository button, we'll actually pull data from a WCF service. So what we have here is a working application, and we're not actually using generics at this point. So why would we actually want to add generic parameters to our interface? Well, let's think about our application a little bit more. So we have the iPerson repository, and this is an interface that's designed to interact with the person object. But generally in our applications, we have more than one object type that we're dealing with. What if we also had a product object? Well, here we actually have a product object, and this is a very simple class. It just has 3 properties: a product ID, a product name, and a category. And just like with our person object, we want to create repositories in order to get this data out of our data store. So we want to create an interface for that as well. And that interface would probably look like this: an iProduct repository. But this is also a CRUD repository, which means it will have similar methods for create, read, update, and delete. In fact, when we look at this, it looks very similar to our iPerson repository. In fact, let's go ahead and look at these side by side. So when we look at our iPerson repository, right next to our iProduct repository, I see a lot of things that look Very similar. So we have a getPeople method compared to a getProducts method. We have a getPerson and a getProduct, an addPerson and an addProduct. I really feel like I should be able to combine these into a single interface so that I don't have to create an interface for each type that I have in my project. Remember, in addition to these two, we probably have things like customers and orders and inventory and all sorts of other objects that we need to deal with. So let's see if we can figure out what the differences are between these right now. Well, the first thing are the names of our methods. We have getPeople versus getProducts. Now we could easily come up with a name that would apply to both, probably something like getItems. That's actually the easiest thing to fix when we're looking at these. But let's look at some of the other things as well. Now the biggest thing are the types that each of these interfaces is dealing with. If we look at the getPeople method, it returns an IEnumerable of person. If we look at getProducts, it returns an IEnumerable of product. So we need to somehow come up with a way that this will work with either person or product objects. And that's exactly what generic type parameters allow us to do. Now there is another difference that we have to look at, and that has to do with the primary key for each of these. Notice that our getPerson method takes a parameter of type string, so the last name is actually the key for this type. If we look at getProduct, we see that this takes an integer, so we actually have a different type for the keys as well. So if we want to combine these into a single interface, we need to do three things. First, we need to come up with method names that will apply across all of our types. Second, we need to specify the primary type that we're dealing with this interface. And the third thing we need to do is specify the type of the primary key for this particular type. And this is what we get with generic interfaces. I've already created one called iRepository. So let's compare our generic iRepository to our original iPerson repository. Now there's three things that we wanted to swap out. First was the name of the methods, and you can see that we have actually done that with getItems, getItem, addItem, etc. So these names would apply to whatever types we give it. Second, we need to deal with the primary type, which is person in our original repository. To do this, we've added a generic type parameter t, and this is used throughout the methods. So we can see that getItems actually returns an IEnumerable of t, meaning we can substitute person for that in our actual implementation. And if we look through the rest of these methods, anywhere we had person in the original iPerson repository is now t in the generic iRepository. Now the third thing we needed to swap out was the type of the primary key. In the case of person, the primary key is of type string because it's keyed off of the last name property. And if we look at the methods in our generic repository, we can see anywhere that we would have had string in our original now says t-key. So because we have these generic type parameters, t and t-key, we can actually use this iRepository interface with any of the types in our application. Now let's talk a little bit about naming the type parameters. So you notice our iRepository has t and t-key. Generally, when we have a single generic type parameter, we give it the capital letter T, which stands for type. Now this is just a convention. You can technically put in whatever you want here. But this is what developers expect because the majority of generic types that we run across actually use this convention of a capital letter T for the primary type. Now, if we have any additional generic type parameters, it's traditional to put a capital letter T and then some descriptor of what it's used for. So in this case, we have t-key, since this is the primary key for a particular repository. But if we look at the extension methods that we have in Link, we'll see generic type parameters with things like t-source, t-predicate, and t-result. So again, even though this naming scheme is not required, it's a good idea to follow it because this is what developers expect. So now that we've seen the generic interface, let's see what it would be like to implement our person repository using this generic iRepository of t-key. Now it turns out I already have one implemented. So if we go to generics.repository, in addition to the person service repository that we saw before, we have this generic person service repository. And if we look at the interface, this actually implements iRepository of person string. So again, we've taken anything that had a T and replaced it with person, and anything that had T key has been replaced with string. So if we look at the getItems method, we can see this returns an IEnumerable of person. And for the getItem method, we see it takes a parameter of type string and returns an object of type person. And if we want to use this repository in our application, it's very straightforward to use. So here, let's just comment out these two lines that we have here. And I'm going to use the keyboard shortcut Control-K, Control-C in order to comment out those lines. Now, our repository type will be a little bit different. It's actually going to be an iRepository of person string, and we'll name it repository. And we'll new up the generic person service repository, that class that we just looked at. Now, we do still need an IEnumerable of person called people, but this time we'll say repository.getItems. We have to remember that we chose our method name so that they would apply to a wide variety of types. Now, the rest of our code in our for each loop actually stays exactly the same. And when we run our application, we'll see that we have the same results that we had before. So when we click on the repository button, it will pull the data from that WCF SOAP service. But now let's take a look at what it would be like to actually implement the product repository. So let's go back to our Solution Explorer. And inside our generics.repository project, I have a class called Generic Product Service Repository. So the idea behind this is just like our generic person service repository, this would get data from a WCF SOAP service. Now you can see here, I just have an empty class at the moment. So let's go ahead and implement that iRepository interface. So here we would say iRepository, and then we need to choose our generic types. So you can see here IntelliSense is asking us for a T and a T key. Well, again, T is our primary type in this case, so that will be product. And T key is the type of our primary key, which in this case is an integer. So we'll just put in int. Now I like to have Visual Studio do all of the work for me. So if you notice here on our interface, we have a little blue underline. That's actually telling us that Visual Studio wants to help us out. If I say Control dot, this will actually pop open some options here. And we see one of those options is Implement Interface iRepository of Product Int. So when we choose that, Visual Studio actually fills in all of those methods for us so we don't have to. And let's go ahead and collapse to definitions. And here we'll see we have getItems, getItem, addItem, updateItem, deleteItem, and updateItems, all of the methods from our interface. And we can see the generic type parameters have been replaced with the appropriate types. So anywhere we had T in our interface, we have product. And anywhere that we had T key in our interface, we now have int. Now we won't go through the process of fully implementing this repository here, but what we can see here is if we look at our generic person service repository, along with our generic product service repository, we can see they use the same interface. So they're using the generic interface iRepository of T key, but because of those generic type parameters, we've been able to substitute the types that we actually need for our repositories. So our person repository has type person with a primary key of string, and our product repository has a type product with a primary key of integer. And as you can imagine, if we were to implement repositories for all of our object types, again, things like customers, orders, inventory, and so forth, without the generic type parameters, we might end up with interfaces for each specific type. But because we have these generic parameters available to us, we can write a single interface that will apply to any repositories that we want to create. So this shows us how generic type parameters can really help us add flexibility and reuse to our applications. So what we've seen this time is generics can add flexibility and reuse to our interfaces. Now there is still a lot more to cover when talking about generics. In upcoming videos, we'll be talking about generic type parameters in methods, as well as delegates, and we'll also be looking at some generic constraints that allow us to more finely tune how our generics are actually used. Now, if you don't want to wait for those future videos, just follow the links on the video notes, and that will take you to a PDF walkthrough that includes this topic, as well as the other topics in this series. Also, you'll find a code download where you can follow along with the samples that we've been showing. So, for more information on generics and other topics, be sure to visit www.JeremyBytes.com.